You don't need to convince me that containers are absolutely the best thing to come out of the virtualization revolution. I use containers of one flavor or another just about every day. But the beauty of template it once and deploy it everywhere comes with a cost. Suppose even a single layer within that template contains a security vulnerability. And if there is a vulnerability tucked away down there, how would you even know? When you build your software infrastructure on a physical server the traditional way, you'll manually acquire and install each element of the stack one piece at a time. The odds are that you'll be pulling the latest version of everything straight from the official source, and you'll at the very least be thinking about each layer. But most modern containers are built from complicated templates. It's easy to just copy and paste the code and fire it up. It's very possible that you might not even be aware of all the software that's powering your application. And even if you are, it would easily take you hours of research into each and every element to figure out where you stand. That's the problem that Chainguard exists to solve. Chainguard provides hundreds of well-maintained custom versions of many of the most popular container images out there. You're free to pull, say, the official MariaDB image into your Docker file. But going with the Chainguard version instead will be a far safer choice. That's because Chainguard is constantly analyzing their image layers for vulnerabilities and building images that are as up-to-date and secure as possible. Let's find out how all of this actually works in the real world. Before we get started building new images, though, I should tell you how we're going to visualize each image's vulnerabilities so we can quantify the Chainguard advantage. First, though, I should explain that infrastructure vulnerabilities are generally defined using the Common Vulnerabilities and Exposures, or CVE, system based on the National Vulnerability Database maintained by the U.S. government's NIST. There are hundreds of thousands of CVE definitions that have been identified and categorized by the CVE system, with each one rated by severity. The existence of this database, along with a number of important related tools, allows us to automate our security assessments. Docker Scout is one of those tools. This page gives you installation instructions for using Scout on Docker Engine, which is what I'm running. It should run out of the box if you're using Docker Desktop. The curl command will simply download the install scout bash script that'll make everything happen. I saved that script to the work directory on this machine. If you take a quick look inside my edited version of the script, you'll see that I updated the Docker home value to point to an actual hidden directory on my system. The default location didn't exist and caused the script to fail. That may or may not be useful for you. I will note that the script is packed full of functionality. As a system administrator, that means I shouldn't be running it without having carefully worked through each line. Alternatively, I can execute it in a safe, throwaway environment, much like the handy LXD container that I created just for this demo, and intend to destroy when it's done. As you'll see soon enough, Scout successfully installed without further trouble. Now I'll move over to the standard directory where I created a Docker file that'll pull the official MariaDB image from Docker Hub. We'll pretend that the image will be used in a multi-tier deployment, so we'll create a root database and password and a new user account with its own password. There might be an application tier instance that'll use these credentials to access the database at some point. Either way, I'll build the image the usual way, giving it the name MariaDB_standard. This won't take long because the base images were already pulled from Docker Hub while I was testing everything. Next, I'll switch to the CG directory where there's another Docker file waiting for us. This one is exactly the same as the first one, except that we're pulling the special Chainguard image of MariaDB. We're also getting this image from Docker Hub, but we could have just as easily pulled it from Chainguard's own repo. Let me build this image and give it the name MariaDB CG. Whoops, I forgot to add the dot at the end. How's Docker supposed to know which Docker file I'm referring to here? I'll try that again. Great. That was also nice and quick. I'll clear the screen and run Docker images to scan the two images so we can compare them. The Chainguard image is, as you can see, quite a bit larger. But note how it's actually a whole lot more recent. Now it's time to put Docker Scout to work. That happens with Docker Scout and then QV, which is short for Quick View. I'll point Scout to the MariaDB standard image first. The standard image is made up of 3 layers, beginning with Ubuntu 23.10, then the Ubuntu 22.04 long-term support release, and then MariaDB on top. Ubuntu has 10 low and 9 medium vulnerabilities, and alarmingly, the MariaDB layer has 2 critical and 28 high problems. This should be enough to keep an admin up at night, and sorting through all of those to figure out which are showstoppers and which aren't such a big deal for your environment will take you a lot of time. Now I'll run Scout against the Chainguard image. First off, we can see that there's only 1 layer here. I suspect that's one way the Chainguard people maintain control over their images. Those 2 critical vulnerabilities are still there, but there are only 5 high severity and no medium or low at all. If you want to dive deeper to find out what's actually there, I'll use the CVEs argument instead of Quick View. We can research each of those using the standard CVE tools and databases to understand them better. But that'll be a whole lot easier than it would have been researching all 28 high-severity vulnerabilities in the standard MariaDB image. If all this makes sense to you, perhaps you want to give Chainguard a try yourself.